Hello friends, this video on thermal properties of matter part 13 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from part 1 to part 12 before going ahead with part 13.
Let us now look at another important property that is known as the specific heat capacity. So what is specific heat capacity? Basically, the specific heat capacity tells us how much heat is required to heat a specific amount of substance by a specific temperature. For example, you are given a specific amount of some substance, for example, say water. I give you water in a bowl and I tell you that okay, you have this much amount of water in this bowl. Now you tell me that if I want to heat it till it reaches a temperature of say 50 degrees Celsius. So how much heat should you apply so that it reaches that specific temperature? So that amount of heat is basically determined by specific heat capacity. Now let us suppose that if I say that the amount of heat required to heat a particular substance is say Q. So basically the amount of heat which is required to heat the substance such that its temperature increases by some amount, say delta T, then we say that the amount of heat depends on three things. I should not say directly proportional, it is basically a function of three things. One is nature of substance, mass of the substance, and delta T, that is the temperature by which its temperature increases. So that means the amount of heat required to raise the temperature of a substance depends on three particular variables. One is the nature of the substance. That means the amount of heat required will vary with the nature of the substance. It also varies with the amount of the substance which you are heating, and it also varies with the temperature, by how much temperature you want to heat it. You want to heat it to reach what temperature. So delta T. So these are the three things on which this amount of heat depends. Now let us suppose that this amount of heat we denote by delta Q. So this delta Q is a product of mass of the substance. Nature of the substance is determined by the specific heat capacity, let us say S into delta T. So we say that specific heat capacity is equal to delta Q divided by M delta T, or we can say delta Q by delta T 1 by M, right? So this becomes my specific heat capacity. Now let us look at how is it defined. It is the property of a substance which determines the change in temperature of the substance undergoing no phase change. That is an important point to note here. When a given quantity of heat is absorbed or rejected by it. So specific heat capacity, what does it? It takes care of how much, by what temperature does a substance, what is the change in temperature that takes place for a substance when a certain amount of heat is absorbed or rejected by the substance. But a point to be noted here is that the substance does not undergo any phase change. What do we mean by phase change? Means it does not change its state from one state to another. For example, if I am heating water, it should not change from solid to liquid or from liquid to gas. So without undergoing any phase change, if there is a change in temperature, then what is that change in temperature when a given quantity of heat is absorbed or rejected by it? It is denoted by S, as I told you here. It depends on the nature of substance and temperature. Now, as we look at this definition, that is S is equal to delta Q by delta T into 1 by M. So from this we can also define it alternately as the amount of heat per unit mass absorbed or rejected by a substance to change its temperature by 1 unit. If you look at this mathematical expression, you can define specific heat capacity as the amount of heat, that is delta Q, per unit mass, right? Amount of heat per unit mass absorbed or rejected to change the temperature by 1 unit, right? So let me write that definition also. Amount of heat per unit mass absorbed or rejected to change the temperature by 1 unit. I hope this definition is easier for you to understand once you remember this expression. So from this we can say that it depends on the nature of the substance. Obviously it is dependent on what kind of material which you are using, and it also depends on temperature. Its SI unit is joule per kg per Kelvin. How do we get this SI unit? Very simple. If you look at this formula, we can say that for delta Q, that is heat. Heat is what? It is a form of energy, so its SI unit would be joule divided by change in temperature will be in Kelvin. Also, mass will be kg. So, we get joule, kg inverse, Kelvin inverse. Now, that is what we know as specific heat capacity. Now, if the specific heat capacity is specified in terms of moles instead of mass, then it is known as molar specific heat capacity. I mean, it is the same thing, just that instead of mass, we use moles, right? That is the number of moles present in any sample. For example, now this is denoted by C. So if it is expressed in terms of mass, it is denoted by S and it is called specific heat capacity. If it is specified in terms of number of moles, then it is known as molar specific heat capacity and it is denoted by C. So that is C will be equal to delta Q by delta T per unit number of moles. So if you remember, the previous one was specific heat capacity was delta Q by delta T per unit mass. So it is just that S is now replaced by C and mass is replaced by number of moles. So even in this case, it depends on the nature of the substance and the temperature, because end of the day it is the same thing, just that instead of mass it is moles. What would be the SI unit? It will be joule per Kelvin per mole inverse. So instead of kg inverse, it is now mole inverse. Now that we have discussed molar specific heat capacity, we will discuss two very important terms. That is molar specific heat capacity at constant volume and at constant pressure. These two terms will be very frequently used as you go ahead, and so let us introduce them now. Heat transfer can be achieved by keeping either pressure constant or volume constant. As I told you, in order to, there are three variables which basically define any particular state of a gas, that is pressure, volume and temperature. So if you want transfer of heat to take place, there has to be a temperature difference, right? Only then heat transfer will take place. Now in order that heat transfer takes place, it is also important that we keep either pressure or volume constant. Now, when pressure is kept constant, then the molar specific heat capacity is denoted by C with P as the subscript, and it is known as molar heat capacity at constant pressure. Similarly, when volume is kept constant, It is denoted by CV and it is known as molar specific heat capacity at constant volume. So these are basically two terms which will be used depending on whether pressure or volume is kept constant.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.